In this video we're going to model this actuator base. And if you've watched exercise number 1, you can see we have some areas that are pretty similar to the object we did in exercise number 1. However, this object is slightly more complicated. For example, we have these corners here, which will be a bit of a challenge. We have to make sure that we get a nice and clean transition when we subdivide this object. The nice thing about this object is that we have some dimensions, and I'm assuming that these numbers refer to centimeters or inches, which means that this object is fairly small. I'm going to multiply all of these numbers by 100 so we can work with a model that is easier to work with. Modeling very small objects can be a bit of a pain. Like in the previous exercise, we're going to start this by modeling the top surface here. And you can see that from this point here to the center of this hole we have a length of 350 units and we have a width of 200 units. I'm going to start this object with a plane that we will be using as a reference, and then we're going to add a disk object and we will use that disk to create the actual top surface here. So let's get started. I'm going to add a plane object here, and this has to be 350 by 200 centimeters. We're going to need one additional segment for the width, but we only need one height segment. So let's make this editable, and next I'm going to add a disk object, switch on snapping, and I'm going to snap the center of the disk to this front line of the plane here. You can see in the drawing that this hole has a diameter of 150 units, so we're going to use an inner radius of 75 to get this opening here, and from the center of this hole to the outside of the object we have a radius of 137. So let's change the inner radius to 75, the outer radius to 137. We're not going to use any segments, and for the rotation segments we're going to use 24. So that should make sure that we keep about the same size once we subdivide this object. Now let's make this editable, and let's select the plane. I'm going to move this point over and snap it to the edge of the disk, and I'm going to copy the position and move this point here to the same position on the x-axis. And now we can select the disk. Let's use the plane cut tool. I'm going to switch the mode to world and the plane to YZ, and we can snap the cut tool to this line of the plane and make our cut here. So next I'm going to select these points and delete them, and we can then select these 2 points and weld them to this point. And let's go ahead and weld these 2 points. And now we can select these edges here and extrude them back. I'm going to snap them to this line here on the plane. So now we can get rid of this plane. Before we extrude this object into a 3-dimensional object, let's have another look at the drawing. You can see that the depth of these extrusions is 37 units, and the length of these extrusions is 150 units, so we have a radius from the center of this opening to the outside of 75 units, which means from this point to this point here we have a diameter of 150. So let's go ahead and use this to prepare the geometry for those details. I'm going to select these edges here, and then I'm going to scale them. I'm going to move the z-axis to -100, and now we can change the size to 37. And up here we have to do the same thing. We could also calculate the distance. We know that this edge is at 100 on the z-axis, so this one here has to be at 100 minus 37. I'm just going to reset the axis, and next I'm going to select these 3 edges here and dissolve them, and I'm going to melt these polygons here. Let's delete these points and then select these edges here and use edge cut with 3 subdivisions to connect the geometry again. So I've done this to space the polygons apart more evenly here. Next I'm going to ring select these edges and connect them, and we can then select these edges here, use scale and move the axis to -100 on the x-axis, and then I'm going to scale these to 150. Let's reset the axis, ring select these edges and connect them, and this will create the center line running through all of these openings here. So now we can turn this into a 3-dimensional object. So let's switch to polygon mode, select all the polygons, hit D for extrude. We're going to create caps, and let's have another look at the drawing here. So we have a height of 37 units over here, and back here we have a height of 137 from the bottom of the object to the center of this hole here. So I'm going to extrude these polygons 37 centimeters. And then let's select these 2 polygons, and I'm going to extrude these without caps another 100 centimeters. Let's get rid of half of this object now. Next I'm going to create this curved section up here, and like in the previous exercise I'm going to use a plugin called Magic Wedge Tool by Nitro 4D to get this round top surface or top area here. So I'm going to delete this polygon here, select this one, and then grab the tool, switch to edge mode, select this edge, and holding down the left mouse button and moving the mouse up and down I can rotate this polygon here, and I'm holding down shift to snap it over to the opposite side. And I'm going to use 8 subdivisions, so that should make sure that we keep the size of this area here when we subdivide the object. Let's go back to polygon mode. We still have this polygon here that's within the geometry. I'm just going to delete this and optimize the object just in case. For the opening here I'm going to use a cylinder and a bool object, and you can see over here that each of these small holes has a diameter of 50 units. So we're going to need a cylinder with a radius of 25 centimeters here. So I'm going to add the cylinder, switch the orientation to +Z, and let's move this over and snap it to this point here. Let's move this over like so, and I'm going to change the radius to 25 and the segments to 16. We're going to need a bit of geometry in this area here, and that's because I want to make sure that we keep a straight line once we subdivide the object, and also we can get a more even distribution of the geometry here. So I'm going to select this object and ring select these edges and use edge cut with 3 subdivisions. And now we can grab a bool object. Let's make the cylinder the second child here, and for the bool object I'm going to create a single object. I'm going to hide the new edges and make this editable, and we can now select these edges here and dissolve them, and then we can use connect points edges to connect the geometry here. And in order to connect the rest of these edges here, we will need some more geometry down here. So I'm going to select these edges and these ones over here, and let's use edge cut, 2 subdivisions, and now we can dissolve these 4 edges here. And in order to get rid of the n-gons that we've just created, I'm going to select these edges here and again use edge cut with 1 subdivision, And let's move some of these points around a bit. I'm going to move these down a bit and maybe scale them. Something like this. Next we're going to create this hole that goes through the top surface here. First of all, I'm going to add a symmetry object, and let's change the mirror plane to XY. Let's make this editable. Having a closed object will just create less of a mess when we use the bool object. We're going to need another cylinder, and I'm going to snap it to the center line of these openings here. Let's change the radius to 25, and let's try 16 segments for now. Now if I switch to wireframe mode, you can see that we have a lot of geometry on this cylinder here. So we can either try and create additional edge loops, or we can reduce the number of rotation segments. And it doesn't really make much sense to create all of these new edges, so we're going to try and reduce the rotation segments. In order to make the bool operation a little bit less messy, I'm going to change the geometry here a little bit. So let's go to polygon mode, using my live selection tool here, switch off only select visible elements, and we can then melt these polygons here. So I'm only going to keep the center lines going through that cylinder here. Let's select the cylinder, and I'm going to change the rotation segments to 12. And you can see this will work fine. We can connect this point to this one, and this one to this one over here. So let's use a bool object, and for the bool object I'm going to again create a single object, and I'm going to hide the new edges. Let's make this editable. I'm going to delete half of the object, and now we can get rid of the n-gons by connecting the points. And let's maybe move some of these points around. So I'm going to move these ones over a bit. Like so, maybe. The last detail we're going to add is this curved area here. Now if I use a subdivision surface object, we will get a curve here, but we don't really have a lot of geometry to properly define this curve. So I'm going to use a bit more geometry to get a nicer definition here. And this should also help in order to get a nicer and cleaner transition once we add the control edges. So let's see, I'm going to make this an even curve from this side here to this side here. So what I'll do is I just connect these edges, and let's select this one. It has a height of 25 centimeters. So what we can do is we can select these edges here, and I'm going to just scale these to 25 centimeters. So now let's select this edge and use the bevel tool. We're going to chamfer this edge, and in order to get a couple more polygons, we're going to use 3 subdivisions here. That should give us 4 polygons. And we're also going to use the limit option here, so we can stop the bevel at this edge and at this edge. So if I bevel this, I'm getting the curve that I want, but I'm also getting this pretty nasty bump in the geometry, and the reason we're getting this bump is because of this edge here. So what we can do here is select this edge and dissolve it for now, and then use the bevel tool, and this will give us a much cleaner result. So next we're going to optimize the object, because the bevel tool doesn't weld the points here at the corners. So if I go to point mode, you can see we have 230 points. Let's optimize the object. First of all, I should deselect everything, and you can see we only have 233 left, so these points here have all been welded. I'm going to dissolve this edge here. Let's have a look over here. We can dissolve these edges, and then we can connect these points. So this is working out nicely. We're getting four-sided polygons here. So that's good. Next, I'm going to add a couple more edges here. So I'm using edge cut with 2 subdivisions. So we're getting a nice straight line when we subdivide this object. And also we're distributing the geometry a little more evenly. We're not going to worry about these n-gons here. We're going to get rid of them when we've added the control edges.